All right, so good afternoon, class. A little review from what we were talking about yesterday. Our four basic forces of flight. So we're going to draw our 172 here. Got JD, our wing, our horizontal stabilizer, our rudder, ailerons. Let's see here, landing gear. So our four basic forces on the airplane. So we have lift, we have drag. So this is what tries to keep the airplane back. So that's friction against the air, having to move through the air causes drag. We have some of our students' favorite one. We have thrust, and then of course opposing lift. We have gravity's effect and weight. So those are our four forces of flight. When we're in level flight, these are all equal. So thrust is equal to drag, lift is equal to weight. If we change any of those, then the airplane will begin to either accelerate, slow down, climb, or descend. So in level flight, all of these are in balance with each other. So that's our four basic forces on the airplane. Now to go on what controls the airplane, our control surfaces. We have our control surface here. This is our elevator. So think of an airplane going up and down, an elevator in a building goes up and down. So this travels up and down this way. So when you pull back on the yoke, the elevator travels up, which this force of air hits this, pushing the tail down, which makes the nose go up. So that's the elevator. If you push the yoke forward, the elevator then goes down. The air striking that forces the tail to go up, which then forces the nose to go down. So up elevator, down elevator. Rudder, if we were to look at the back of the airplane, so we've got our tail section here, so a vertical stabilizer, and we have our horizontal stabilizer. So the rudder moves from side to side. It either goes to the left or it goes to the right, whichever one you push. That controls our yaw. So if we're looking at the top of the airplane, so here's our wing. So when we do our rudder, left or right, that controls the airplane. The nose either swings left or right, depending on what direction our rudder goes. So that's yaw. So we have pitch, we have yaw, and then our final is roll. So if we look at, again, the back, actually we look at the front of the airplane. So here's our front of our airplane. So roll is our ailerons. So if we want to bank the airplane to the left, we want that left wing to go down. So that aileron is going to go up, forcing that wing to go down. And this aileron is going to go down, forcing that wing to go up, which makes our airplane then roll this direction. And if we want to go the opposite direction, then this aileron is going to go down, this aileron is going to go up, which is then going to make this wing go up, this wing is going to go down, and our airplane is going to roll in the opposite direction. So we use these primary control surfaces in coordination with each other to keep the airplane coordinated and flying smoothly through the air. So when we go up and fly, we'll go out, we're going to do some demonstration on the controls, really learn what they do, how they work in conjunction with each other. Probably do a dynamic stability demonstration where I'll show you the stability of the airplane. So we're going to go up, we're going to pitch the airplane up, nose up about 15 degrees, and all we're going to do is just let it go. And you're going to notice the airplane's going to pitch up and it's going to start slowing down. As it slows down, it's going to pitch back down a little bit, and the airplane's just going to kind of go through a couple oscillations, and eventually it'll level back out on its own. So that's the stability that's built into the airplane. And we'll talk about stability and dynamic stability as it pertains to the design of this particular airplane. I look forward to flying with you. Bye.